Can they see me too?
Yes, we're live. Hey, everybody. Thanks for connecting with us. The webinar today will talk about unleashing the wine aromas during fermentation. My name is Federico, and I'm the scientific advisor for IB USA. And today on the screen with me is Marisa Webster, that is the sales rep for Central Coast and Temecula for IB. While we wait to everybody to connect, I just want to say a couple of words on my background. I'm a biotechnologist. I studied industrial biotechnology and beer fermentation and wine fermentation, especially non-conventional yeast fermentation at the University of Adelaide. This webinar is a part of an initiative to stay connected with you during this pandemic, and I think we are ready to go. So the webinar is going to be divided in 3 different steps. The first step is going to be a brief presentation on an experiment that I did during my PhD at the University of Adelaide. The second part is a poll. If you see below your screen, I prepare already 9 questions for you to answer during the presentation or after the presentation. And at the end, we'll go through the answers. And at the end, we will have quick answers of your questions. You can write your question on the chat, or you can write your question on the question button below the screen. I think the total time will be around 30 minutes. So every wine is characterized by a different bouquet because it has different compounds in it. And these compounds could be deriving from grapes, or could derive from the fermentation, so from yeast, or could derive from aging, and so from the wood. During this presentation, we're going to talk about how you can influence the fermentation-derived aromas. So we need to understand what's happening during fermentation. During fermentation, the yeast eat glucose and fructose and other important elements, such as nitrogen, to produce ethanol and CO2. And alongside ethanol fermentation, it produces a broad variety of secondary metabolites, some of which are very aromatic, volatiles and very aromatic, such as esters and higher alcohol. The yeast could also take some flavor precursor that are in the grapes and release them and making them volatiles. While for some grape flavors, the yeast cannot do anything, and one example are the methoxypyrazine. As you know, if you ferment the same grapes with different yeast, you can obtain different style of wine. So the researcher tried to understand why different yeast produce different aromas. And the first step was to identify which chemical compound are associated with which sensory descriptors. And so they identified the compounds that cause tropical aromas, or the compounds that cause varietal expression. And the next step was to identify the genes of the yeast that can promote, so overexpress or reduce this aromatic production. And the research showed that for this de novo biosynthesis aromas, the amino acid metabolism, the sugar metabolism, and the lipid metabolism are very important. Also, for the release of the grape flavors, research show that the yeast needs to produce some enzyme to release them for their bounded form. In the particular case of volatile tiols, there are two precursors in the grapes, 4-MMP and 3-MH, that are bounded to cysteine or glutathione. The yeast need to produce the enzyme to release them in your wine, and the particular case of volatile thiol is that the yeast then take 3-MH and make an acetate ester of it, that it's called 3-MHA. The sensory descriptor of this compound are shown on the screen. And as for the de novo compounds biosynthesis, different yeast release different amount of volatile thiols. And the genetic sequence of the different yeast has been analyzed, and the release of volatile thiol has been linked to these genes, IRC7, that is a beta sulfurlyase that the yeast produce and can cleavage the link between a sugar and between the cysteine or glutathione to the volatile thiol. So the aim of this experiment was to see how we can explore this wine yeast flavor spectrum with yeast selection and addition to be able to give winemakers tool to give in the direction that they want with their wine. And to do it, the experiment included two different yeasts. One yeast that is been selected to release more volatile thiols because it has the IRC7 gene, and one yeast that instead produce a lot of glutathione that is an antioxidant, and so it can protect more the volatile thiols from oxidation. Yeah, glutathione is a very antioxidant molecule. And another treatment was the addition of an enzyme. It's an enzyme that is characterized by this beta sulfurlyase cleavage activity. So it's an enzyme for the release of the thiols. And also the treatment included two organic nutrients addition. One is yeast extract, and one the Thermoplast DAP3. And the Thermoplast tropical is a yeast extract targeted for the tropical aromas production. And right now I'm going to explain you why organic nutrients and amino acid based nutrients are very important for wine fermentation. Research show that amino acids are better than DIP to promote fermentation. But there's not one amino acid that does all the job. Each amino acid can promote different stages of the fermentation. There's some amino acids that are better for the exponential phase of the yeast. There's some amino acids that are more helpful for the yeast to rehydrate. And there's some amino acids that help the yeast produce more aromatic compounds. In fact, when you give an amino acid to the yeast take in the amino acid and take out the nitrogen, and it doesn't know what to do with the remaining of the molecule. And to get rid of it, it produces CO2 and it reduces the molecule to a higher alcohol. It is very aromatic. When the higher alcohols start accumulating, because they're toxic, the yeast detoxify the media, making them volatile, and so condense an higher alcohol to make an acetate esters. And the same things happens with lipids. When they become toxic for a cell, the yeast make ethyl esters that have a broad range of different aromatic compounds, and each yeast strain is able to have a different fingerprint for these esters. And to study the different conditions, we tried it in two different grapes. One, I did the experiment at the University of Adelaide, so we used the grape from Australia. One at the different spectrum of the thiols precursor. One was Sauvignon Blanc, that is high in tiol's, and the other one was Chardonnay, that is low in tiol's, but has been proven that maximizing the tiol can increase the potential of your wine. So for doing all these conditions, we use this robot at the University of Adelaide that can do 100 fermentation in the same times. And the condition was control, enzyme addition, low nutrient, high nutrient, first the DAP-free, low nutrient, high nutrient, the tropical, and the enzyme plus one nutrient and enzyme plus the second nutrient. Everything was in triplicate for 2 yeast for 2 varieties. So at the end, 96 different fermentation. And the result of experiment is, as predicted, organic nutrients reduce the fermentation time, so help the yeast fermenting faster. Regarding the tiol production, the Sauvignon yeast was more efficient of the other yeast to release tiols. At the beginning, with no addition, they were pretty similar, but with the addition, clearly the first yeast was more able to release volatile tiols. Regarding the use of the enzyme for free MH in Sauvignon Blanc, we can see that all the treatment with the enzyme that are in yellow have an increased free MH concentration. And in particular, if we see just the enzyme addition, it increased 3 times the concentration of free MH in your wine. It started at 1,200 and it finished at 3,500. For free MH, the nutrient, we can see that tropical, the organic nutrients, both increase the free MH concentration. However, the tropical was more, had a bigger impact on the free MH production, that is quantified again 3 times more using the nutrients. For free MH, what we can see is as the concentration increased with the use of the enzymes 3 times. However, with the use of the nutrients tropical in Sauvignon Blanc, we get a 20 times increase of the free MHA concentration in wine, in the final wine. Regarding Chardonnay, if you see the scale is different compared to the one for Sauvignon Blanc, Chardonnay has less precursor, so it has at least 5 times less precursor for free MH, and in fact, the addition of an enzyme could increase the free MH concentration, but this time it increased only for 1/3 more. The nutrients has the same effect of the enzyme, increasing 1/3 more the concentration of free MH. And for free MHA, instead, we can see a 6 times increase following the enzyme addition. And again, with the nutrient, we can see that the tropical is the more effective to increase this free MHA concentration, and we can get a 6 times increase of these compounds in the wine. After analyzing the tiols, we analyze all the esters and higher alcohols, and we can see in this PCA graph, on the right side, you see all the result of the one yeast, and on the other side, you can see the result of the second yeast. And so the graph is saying that the bigger differentiation that you can get in your wine is based on the yeast selection. However, as you can see, the different treatments are not all together, but they're spread on the graph. So it means that you can still influence the aromatic compounds production depending on the addition that you do. And to make it easier, we cluster the ester production based on their aroma descriptor. And what we saw is that the enzyme addition didn't really influence the ester and higher alcohols production, while the nutrients addition really increased all the fermentation aromas and bouquet in the final wine. Again, with the tropical, with more of this ester production because of this targeted amino acid concentration. So the conclusion of the experiment is the biggest choice that you can make is to select properly your yeast based of what you want to achieve, keeping in mind that a yeast cannot perform if it doesn't have enough nutrition. So you have to choose your yeast based on what you want to achieve aromatically and what your nutrients, your yan of the media is. The second is that the enzymes can promote the release of volatile thiols in your wine, while the organic nutrients, because it's boosting the metabolism of the yeast, is not only giving the yeast building blocks for creating more esters, but it also increasing its production for itself of this enzyme, and so it increase the volatile thiols too. So the take-home messages from the presentation, if we go back to the wine spectrum, is the first things you have to choose is what base aromas you wanna have. For example, you can have floral or tropical or lime. And second, you can decide which addition depending on what you want to achieve. You can use an enzyme to increase the grapefruit aromas, for example, in Sauvignon Blanc, with a very grassy grapefruit Sauvignon Blanc, or you can use the enzyme to add a layer of complexity in your Chardonnay. I think one thing to keep in mind is the time of addition is very important, because if you add early on, you enable the yeast to produce free MHA. If you put at the end of fermentation, you will have only the free MH. So depending on the time of addition, you can tweak the aromatic compounds that you are producing. Alongside the enzyme, you can instead decide to go for a nutrient. And with the nutrients, you can create a more complex bouquet of tropical in Sauvignon Blanc, or you can try to maximize your fermentation aromas if your Chardonnay doesn't have a lot of varietal characteristics. And in general, organic nutrients are very good to ensure proper fermentation, providing and giving you a healthy yeast. All right, so thank you for attention. This was the presentation. Do you have a question for me, Marisa? No, all right. So if I'm gonna, 1 second, I'll stop sharing, 1 second. If we're gonna see
a section here where you can ask questions.
Yeah.
If anybody has any, right next to the polls.
Yes. So the timing. One question is the timing of addition of the nutrients. The timing of addition of the nutrients depends on your nutrients composition, because as I showed you before, depending on the amino acids that are enriched in your nutrients, it can have different positive effect on the fermentation. So IB nutrients are targeted for specific physiological state. In general, organic nutrients are better at the beginning of fermentation and at 1/3 of fermentation. So if we are going and see the pool result, all right. So just 1 second. The first, let's make it see. The first question was about the first question of the pool was, where are the thiol precursors more abundant? And you voted in the skins. However, like there's different precursor in the in the grapes, and the free MH is founded in the skins, while the 4-MMP is most found in the pulp. The second question was regarding does bentonite reduce thiol concentration? The answer is yes. It reduces thiol concentration and you reduce the aromatic compounds in your wine. However, the results are contradictory, and this is because there's a lot of bentonite out there, and they have different composition. This study, published in 2017 in American Journal of Enology and Viticulture, is done with our bentonite, pharmaceutical grade bentonite, sodium bentonite, bentogram, and is showing how if you use it at the end of alcoholic fermentation, is better for volatile thiols, because bentonite can strip out your thiols binding to the precursor. So it's better to have the thiol volatiles, because the bentonite have a more interaction with the precursor. And this is regarding our bentonite. The third question is, what thiol characteristic do you prefer in your wine? And the most voted is grapefruit. So grapefruit is the sensory descriptor for free MH. So you should aim for release more free MH. The passion fruit is more related to the free MHA, and high concentration of free MHA are responsible for the cut, urine, sweaty aromas. If you want green grassy, actually is not a thiol that causes the most green grassy, but it's called hexanol, and this compound is it has a higher concentration in the skins of the grapes. The next question is which yeast gene is involved specifically with free MH production? And all of you voted for IRC7. However, I asked specifically with free MH, and if you remember during the presentation, I said IRC7 is useful to release 4-MMP and free MH into the media, but after the yeast produce the acetate of the free MH. So the yeast involved specifically in the free MH production is actually the esterases of the yeast, and the most functional esterases of the yeast is called ATF1. I got you on this. Next question is which non-conventional yeast is a potent thiol producer? And every of you vote correctly. The Saccharomyces baianus is usually high glycerol producer. The Lachantia thermotolerans is a lactic acid producer, is a heterofermentative yeast. It produces lactic acid from sugars, so it helps you reduce your pH and increase your TA, while Torula spora has a functional gene for the thiols, and is the yeast that can express it more than others, because it's not only if you have the genes, but it's how much you express it. And Torula spora is very good in express these genes. The next question is, which country has more volatile thiols concentration in wine? This was an easy one. Yes, New Zealand. New Zealand has an average higher than any other country. France is the second. Next question is, which single variety red wine has higher thiol compounds free MH concentration? And most of you voted for Cabernet Sauvignon. However, from the latest measurement, is actually Pinot Noir and Grenache that have the most free MH concentration. You can see that the variation is high, but the average of the Pinot Noir is higher. And an interesting study that has been done, they spike the wine with these compounds to see the effect on the aromas, and the 3MH and 3MHA actually are causing a red fruit expression in red wines without the sensory descriptor of tropical or sweaty that you can find in a red wine, white wine. In a red wine, you have red fruit expression if you maximize your thiol. And yeah, IB has a yeast for thiols for reds, and without a lot of fantasy, we call it thermal red fruit. Next question is, which grape varieties produce the smallest amount of thiol precursor? You voted Chardonnay. Instead, the lowest is Riesling. Riesling has the lowest is the lowest producer of this thiol precursor. However, Riesling is a high producer of terpenes. That is another group of compounds of this grape flavor derived. And so the aromas of the Riesling characterized by other compounds. Chardonnay is still on the low spectrum of this production. Next question is, which of these amino acids is not related with aromatic ester production? And you voted valine, and is correct. Phenylalanine is responsible for 2-phenyl acetate production. That is, the sensory descriptor is rose floral, and is the amino acid that is enriched in our floral organic nutrients, while both leucine and isoleucine help produce isoamyl alcohol and isoamyl acetate for leucine, which are the amino acids that are enriched in our tropical nutrients. Yeah, so let's see if we have some other question. Is the time? The temperature of the addition of the enzyme, it matters. However, the enzyme is only functioning based on dose and temperature. So if you're working at very low temperature, you should increase your dose. And if you work with high SO2 concentration, you can increase your dose. So another question, will cold soak in Sauvignon Blanc increase the green aromatics? Yes, doing some skin contact of Sauvignon Blanc could increase your grassy aromatic in your wine. Another question is glutathione produced a substitute for SO2 or used in conjunction? So glutathione can be a substitute of SO2. However, glutathione has only an antioxidant activity. It doesn't have an antimicrobial activity. Yeah, but it's very helpful to protect your thiol. So what we recommend during fermentation is that once you decided your enzyme addition, or your fermentation is going, and you can see the volatile thiols produced, is to add yeast-derived products rich in glutathione, because both of them have high antioxidant properties. I think we are at the end of this webinar. Thank you for connecting with us. If you have any, I saw a question. So Bentogram is the best added possible. Yes, so Bentogram regarding aromatic preservation is best to being added at the end of the fermentation. So yes, I was saying thank you for connecting with us. If you have any questions, you can contact me or Marisa, or you or your local sales representative. You can subscribe to our YouTube channel, or you can sign up to our newsletter. Please, if you want.
And Federico, about would it help using 2 different yeasts in the same inoculation? So
yes, it's very famous technique to co-inoculate Torula spora and Saccharomyces, or do sequential inoculation depending on how much fingerprint of this yeast you want on your wine. Yes, we're going to share the presentation. If you contact your sales representative, we're happy to share. You can find these videos online on this channel or on our channel on YouTube. Thanks for coming, and it was a pleasure to speak with you. Bye. Ciao, Marisa.
thank you, everyone.